This is video number 3 for sections 8.1 and 8.2, multiplying and dividing rational expressions. We will cover adding and subtracting rational expressions in the next lesson. That's a little bit more difficult. But in this video, we'll talk about multiplying and dividing them. And kind of like I did in the last video, I'd like to start out by just thinking about how you do multiplication with plain old fractions. Because the same ideas that you use here are going to match the ideas that you use when it gets a little bit more complicated. Okay, so when you look at this problem, how would you work it out? Maybe what you're thinking is, oh, you just multiply across. And that is true. I am going to eventually do that, but I certainly don't want to do that now, and it's really impossible to do that in these problems. What I always want to do first is I want to look for opportunities to reduce or simplify before the stuff becomes too big to work with. If you multiplied 8 times 15 or 9 times 12, you're going to get some pretty giant numbers, and it's going to make the reducing much more difficult. So instead, we look for opportunities to divide out common factors now. It's the same idea as from the last video. Any common factor on the top is fair game with any common factor on the bottom. And I think with numbers, you've probably done this for so long that you're used to just seeing the factors in your head. For example, when I look at the 8 and the 12, the number that pops into my head is 4. 4 is a common factor of those two numbers. Well, that means I can divide the 4 out, leaving me here with a 2 and here with a 3. I didn't actually write down the 4, I just divided it out in my head. Another thing that catches my eye is the 15 and the 9, because there is a common factor of 3 in both of those numbers. I could also use the 15 and the 3 if I wanted to, because there's a common factor of 3 in those numbers. It really makes no difference. Anything on the top is fair game with anything on the bottom. I'll go ahead and work diagonally. If I divide this guy by 3, I get 5, and this guy by 3, I get 3. I always want to make sure there's nothing else in common, and I don't think I've got any other common factors top to bottom. Once I've exhausted all of those, then I will multiply across. 2 times 5, 10 on the top, 3 times 3, 9 on the bottom. One advantage of this method is you know that your final answer here is already reduced. I don't have to look for any more common factors. I found them already as I was going through the process. Okay, let's take those same principles and try to apply them to this fresh example. I did notice on this version of the handout I had a couple of typos here at the front of these examples, so if your handout has that as well, make sure to cross those out. I've got a multiplication problem first, and then I've got a division problem second. Let's start with the multiplication problem. Well, again, eventually I'm going to be multiplying across. That's how you multiply fractions. But like in the last example, I don't want to do that until I've had the opportunity to reduce, to divide out any common factors. Well, we went through this in great detail in the last video. You cannot reduce anything until you are looking at giant multiplication problems. With those numbers, it was pretty easy because we just imagined the factors in our head. That's not going to work here. So you need to write out the factored form of all 4 problems. That's right, you need to factor 4 pieces now before you can do anything else. Let's go ahead and do that. The top one here, I see a GCF of 5, so I can pull that out, leaving me with x minus 4. The bottom part, well, I luck out here. I was expecting to factor 4 things, but I can see quite clearly that this already is a giant multiplication problem. I'll put the dots in maybe to emphasize that, but it already is a giant multiplication problem. X squared means x times y times 3. It's all set. Likewise, the first one on the right is already a giant multiplication problem, so nothing needed there. But the bottom one, on the right is not a giant multiplication problem. I'll have to factor it. I think I do have a GCF of 3 and x, and that leaves me with x minus 4. Okay, once you're looking at 4 giant multiplication problems, then and only then can you start looking for common factors top to bottom. Again, anything on the top is fair game with anything on the bottom. I'm sure the one that really stands out to you is the x minus 4. I have that in common here, and I have that in common here. Great. What else? Let's see. I'm looking at the numbers. I do have a couple of 3's, but they're both on the bottom. So, and 5 doesn't have anything in common with a 3, so I think I'm stuck there. How about plain old x's? Well, I actually have several to choose from. I have one here on the bottom. That might be the easiest place to get rid of it. Or, if you like the diagonal thing, I could get rid of one of these x's. You can't do both because I've only got one to play with. So I think I will just get rid of this one here and this one here. Again, anything top to bottom is fine. And then let's see, how about y's? Well, I have one y down here, and this just means y times y. So I could get rid of one y here, and one of these y's would leave me with just a single y left. I think I've gotten rid of now all the factors that were in common, and so all that's left is for me to multiply across. Here I've got 5 times 1 times 1 times y. That makes 5y. And on the bottom, I've got 3 times x squared times 1 times 3 times 1 times 1. The 1's aren't really doing anything. They matter if there's nothing else there. Then, of course, 1 times 1 would be 1. But in this case, I just have 3 times 3 would be 9, and put it with the x squared, and I'm finished. I have nothing else in common top to bottom, and so I know this is my final answer. So again, to recap the steps, first, you have 4 factoring problems to do. Then you can look for common factors to cancel out, and then you multiply across. Let's try this process one more time with this division problem. I'm sure you remember from working with fractions that dividing fractions is almost exactly the same as multiplying, with one twist right at the beginning. And that is, we cannot directly divide by a fraction, and so we have to change it to multiply by the reciprocal. Let's do that quickly first. All right, so all I've done, I recopied the first fraction and I reciprocated the second one, and now I have a times problem, times this second new fraction. Well, from this point on, the steps are essentially the same as what we did in the last example. I will eventually multiply across. I will eventually do some canceling, but none of that can happen until you do 4 factoring problems. And this time, I really think it is 4 factoring problems. I don't have anything that's expressed as a giant multiplication problem. So this is going to take me a while to set up. If your brain is telling you to cross out similar letters right now, that is incorrect. You have to factor first. We'll take it one at a time. Upper left, I have a GCF of x, leaving me x minus 7y. So that was pretty straightforward. The one underneath, I have a GCF of 6, leaving me x minus 5. Okay, let's see. The one up here, I do have a GCF, and then I suspect it's also going to keep going. Let me go ahead and pull out the GCF here as kind of a starting step. So I pulled out the 2, and now I think down here I need to go ahead and I need to continue to factor that other piece. It has 3 terms, so that makes me think FOIL. The numbers look pretty easy, so I don't think I would do Xbox. It's got to be X and X at the front here. 15, let's see, it's either 1 times 15 or 3 times 5. I need to make a 2, so I think that'll take a 3 and a 5, and I'll need the 5 to be negative. Negative 5x plus 3x makes negative 2x, so I think we've got that all set. And then the bottom one, Let's see, I don't see a GCF. This one has two terms, minus sign in the middle. That always makes me think maybe it's difference of squares. Sure enough, this is a perfect square, 7y times 7y. This is x times x, so it's going to fit that a plus b, a minus b situation. A would be the 7y, and b would be the x. Okay, so I have four giant multiplication problems now. Now it's appropriate to start looking for those common factors to cancel. I see I have x minus 5 along with this x minus 5. What else? I have a couple of plain old numbers. 2 and 6 share a common factor of 2, so I could divide out the 2 on the top as well as on the bottom. Let's see, do I have any other of these factors that match? The only other one that's kind of close is the x minus 7y and the 7y minus x. It's like that other one we did in the last video where we were talking about two factors that are almost the same, they're just reversed because of the minus sign. That's that one where you take the one that looks backwards. To me, this is the one that looks backwards because we usually go in alphabetical order. You factor a negative sign out of it, and that allows you to then cancel the two factors. Last time I wrote it out in great detail, but honestly you don't really need to as long as you understand the idea, because the same thing happens every time. I'm going to pull a negative sign out of this guy, which reverses it and allows me to cancel it with the one on the top. So that's enough work for me. I would understand what you're doing if you simply cancel them and then include that extra negative sign. Okay, I think we're out of stuff to cancel out, so we're ready now to put all this together. Let's see, on the top I think everybody disappeared except the x and the x plus 3. On the bottom, what do I have? I think I have three things. I have that negative sign, I have the 3, and I have the 7y plus x. Well, just like the last video, if you end up with a negative on the bottom like that, it's really preferred to have it on the side. So let me rewrite this with that negative on the side. And then maybe you're wondering, well, aren't you going to multiply that stuff out now? Well, the great thing in these problems is we really prefer that the answers be left in factored form. So this is considered the best possible way to write the answer. The reason for that is that anybody looking at this immediately knows that it's already been reduced. If you were to multiply this out, I would have to then factor it back to check to see if I could do any more reducing. So please leave your final answers to these problems in factored form. As I mentioned, in the next lesson, we'll talk about adding and subtracting these guys. That's a little bit more difficult because of the whole common denominator issue. Make sure you really spend a lot of time practicing this stuff so that you'll be ready for that lesson when we get to it.